Okay, so on to question number 2. Draw the Lewis structure for a nitrate ion, NO3 1-. Assign the formal charge for the central atom, which is nitrogen. What is that formal charge? Okay. So for Lewis structures, we first need to figure out the total number of valence electrons in this ion. So in the case of nitrogen, there are 5 valence electrons. And in the case of oxygen, there are 6 valence electrons in a single oxygen atom. So we multiply this by 3, since there are 3 oxygens in the ion. And now notice that it has a -1 charge, so we are going to add an extra electron to our count. So if we add this all up, we should get a total of 24 valence electrons. So now let us start to write down the Lewis structure. We have nitrogen as our central atom. And then I'm just going to draw oxygens all around, just with single bonds. And now notice that nitrogen does not have a full octet yet. If I were to add all the lone pairs of electrons on all of the oxygens, then nitrogen would still not be satisfied. So I'm just going to make one of these oxygens have a double bond. And now I'm just going to draw in all of my electrons and then count to see how many I've drawn and if it all equals 24 electrons. Okay, so I filled in all of the lone pairs on oxygen. So now let's count out how many I've drawn. So these two have 6, so 12. And each bond contains 2 bonding electrons. So we have 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 valence electrons, which is good. And all of our atoms have a full octet. So now let's try to find out the formal charge of all of these atoms. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons. So all of the non-bonding electrons are the lone pairs. And then we're going to subtract the number of bonding electrons divided by 2. Okay, so now let's calculate the formal charge of one of our oxygens. So one of the single bonded oxygens. So I'm just going to say formal charge. I'll just say formal charge of single bonded oxygen is equal to the number of valence electrons, which for oxygen is 6. The number of non-bonding electrons, so if we count out all the electrons in the lone pair, we also get 6. And the number of bonding electrons. So each bond contains 2 electrons, and there's just a single bond, so it's just 2 divided by 2. So 6 minus 6 minus 1 is equal to -1. So now I can show that these two oxygen atoms will have a -1 charge. Okay, so now let's do the same thing for our double bonded oxygen. So I'm going to put double O. It still has 6 valence electrons. This time its number of non-bonding electrons is only 4. And its number of bonding electrons, there's now a double bond. So we have 4 bonding electrons in total, divided by 2. So 6 minus 4 minus 2 is just 0. So our double bonded oxygen is neutral. And lastly, let's calculate the formal charge of our nitrogen. So nitrogen has 5 valence electrons. There are no lone pairs on this nitrogen, so for the number of non-bonding electrons, it's just going to be 0. And in total, there are 4 bonds to the nitrogen. So this means that we have 8 bonding electrons, and we just divide that by 2. So 5 minus 0 minus 4 is positive 1. So that means our nitrogen has a positive charge. And if I'm going to draw it over here. If we look at the overall charge of our molecule, we have 2 -1 charges and 1 +1 charge. So the positive and the negative will cancel each other out, but we still have an overall -1 charge, which is expected, so this is what we wanted. So we know that this will be the correct Lewis structure for the nitrate ion. So now let's see what the junior tutor said. NO3-, the number of valence electrons is equal to 24. Nitrogen is the least electronegative atom, so it is the central atom. Each atom should be surrounded by 8 electrons to satisfy the octet rule. Formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of shared electrons divided by 2. So the formal charge on nitrogen has a +1 charge. And they showed all of the other charges on the atoms, which is good. So this solution is correct.